Hello and welcome. So, in the last session, we discussed or found out that Rust's regions might be tricky if we go over huge amounts of iterations, right? And it made me wonder what does actually Rust compile to in a way? How does it handle like compilation steps? And I came to Rust's playground just to see if we can have some fun with it, at least for a short while, right? As you see, we're just going deeper into the pleasure and we're gonna get some experience in here. So, what does this compile to? Well, obviously bytecode, like actual representation, a binary. But Rust's playground actually shows us a bit more. So when we run it and we wait for the result, Rust is going to show us some sort of intermediate uh, compiled state. So it shows us build and show resulting MIR, Rust's control flow based intermediate representation, which is interesting. So what it does is actually it uncovers the code we have and generates something new, something we didn't write. So this sugar syntax sugar we have gets unpacked into something else. So there's some main function which is deceiving. We didn't write stuff here, so what the hell is this? And actually there's another main in there and another main in there. So what the hell is happening? So according to comments that the MIR thing shows us, it 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 cancels out some readable information for us as developers. Let's look at that. So this is the output thing. So apparently this is for print stuff. I kind of checked it out a bit. So it's doing something, there's an object of some sort, there's something being moved a bunch of variables are being defined, which are not readable by us, but the code knows what it is. And apparently this is something to print out text, because it also prints something, it moves something. Apparently there's some internal movement of maybe a string happening. I don't know, but this is fascinating. So let's look at here, the other main function. It reads a bunch of arguments, so if this application thing was a command line application, it would probably be able to accept a bunch of parameters, right? You would in CLI, in terminal, write your program name and parameter equals this or that. So you would provide some variables and the main function would read it. Maybe it is doing just that exactly, but it's interesting to know. And then in the end, we see another variables in another main, um, some variables, and we access the bb something, which has a looks like a yeah, it's a slice of string. It writes it inside a mutable variable, and then it does something with it. What the hell is bb0? There's a bunch of things going on, and so looks like it's trying to define a scope or something. Look here how it handles it. There's scope 0, value slice, data allocation, some sort of bytes, which is probably our string. So it's bytes of string. So this is probably uh, some part of hello world. And look at the amount of sync it's doing for us. Shit. So it's probably a string object being printed out somehow, which is cool. And then it, whatever, maybe this is a way to maybe this is a way to call the printing thing. I don't know, because from here it's not actually um, visible how it's being executed. But there's a bunch of stuff here. There's something promoted in here, which is interesting to investigate a bit further in the future. And this thing, well, it's not promoted in any way, anyhow, whatever. So maybe, just maybe, this is just a representation of the same function here in different manners. I don't see a hello world string in here, but it does look like there's a bunch of things being so this is the only place the print is used. So this is fine, but it's kind of complicated. So print function apparently is using uh, a bit more than I can understand at this point. Um, maybe let's have a simpler example, like let some variable be equal to i32, like a 32-bit integer, and have it equal to 1. Will this even compile? Let's compile it to just, yeah, let's build and run it. So it's gonna throw probably a bunch of warnings that I is never used, which is just what happened. And I can prefix it with underscore just to make the compiler shut up. What the hell is it gonna compile to in intermediate states? Okay, there's no warnings. MIR. So this is the inner stuff that's fascinating. I mean, Python is fascinating on its own. It's being it's tracking every variable it has, like in the garbage collection. JavaScript does it the same, but these languages, static compiled languages without garbage collection, they do something else. They do some compilation steps that are beyond my reach. I mean, I could understand some abstract syntax tree, but this is whole another level. So what did this compile to in MIR representation? So, okay, there's some, is it tuple? I haven't used tuples in Rust yet. So there's my variable, it's being called underscore 1, and it's defining a scope with some debug, and I is equal to whatever I had. So maybe when the code is actually compiled without any debug information, this would not even appear in the code, and the compiled binary would be way smaller because it wouldn't need to output any shit. So, all right. So i32. So yeah, the debug variable is equal to whatever I had, and apparently the variable underscore 1 is getting 1 as integer and 32-bit representation. And what is BB0? Is it command line thing again? Like whenever if we write a command line application, if we write a command line application, will it, yeah, it could return some values. Maybe it's doing just that. So it's preparing an object to output. I don't know. A lot of assumptions here, but this is a thinking process and something that I would remember in the future. Well, if I set this to 7, will it do the same thing and write as 7 underscore 32? And it does write 7 underscore 32. This is fascinating. This is fascinating. So I was wondering if, so see, this is way smaller code. There's no print functionality, so the code is smaller, which is fascinating on its own. I was wondering how enums work. Previously in session number 1, I made a assumption. I made an assumption that enums, when we hold a whatever struct in there, are compiled to something with indexes or IDs. What's the variable ahead? AAA. So 4 A's. Was it correct to define the enum like this? Okay, let's check it out. So str, no, let's str, not ss, not that guy. Um, I don't remember. I think it was like this. String. I don't think it's gonna yell too much. I mean, I didn't use it, but it should be compiled. Okay. Okay, that code. We've got that code, but still it's compiled. All right. So apparently AAA is now a function. The enum thing that we described before is now a function. No, it's a class. A struct. Sorry. So there is something that is associated with AAA struct. So apparently it was a struct somewhere. Who defines AAA here? So in Rust, when you have this sort of functionality, you've got a struct defined somewhere up top, and you would associate functions with it. Okay, so we provide some string to it, and it generates AAA thing. So this is our struct. It's probably a struct, and it returns 0 as string, and it moves 1. So this thing we provided to it adds a discriminant. What is discriminant? What does it mean? Distinguishing feature or characteristic, or a function of coefficients of a polynomial equation whose value gives information about the roots of the so whatever it means, it says that the thing that we associate with discriminant is the type of a struct we had, and it's gonna be a 0. So we associate a 0 with a type of struct we return. Okay, and then there's another almost a copy of that functionality, but it returns strings and string, move one. It's the same, and we never use it, so whatever. Let's add another thing here with a number, and maybe it's i32 since I know how to write it. Bam. So NMR is now used in the same manner as we had with strings, and now as discriminant it's associating for a number NMR thing index 1. So you see string is 0 and number is 1. So I was right. The way it knows in enums, like when we do a match statement, so let's write it here. Let be, yeah, let it be equal to AAA and MR and type in 2. It's gonna be that code too, but at least we will see how this thing is allocated in the main function. So we will be able to see number discriminant maybe somehow. So let's build it. And then we'll add a match and see. Oh, come on. What's wrong here? Oh, I need to add semicolon. Do you feel that dorkiness inside you? This is fascinating. Yeah. It's gonna take a lot of strength not to rub out now. So in the main function we apparently it's creating a scope 1 debug I something. This is for the i32. The number 2 variable we have is for AAA, and in this scopes 2 debug statement, oh, there's multiple scopes right here even. There's a reference, oh no, it's a setting to be a variable to a like as a value, as a reference. I'm not sure how in this representation it's actually working. So in the one, so for I it sets the number 7 and 2, which is referencing the B. Yeah, B is 2. It sets its value to 2 as I32. Discriminant 2 is 1. We know for sure that, so you see, it's gonna typecast a thing on this level for us. Under number 0, there's probably a value. And it's gonna say, okay, for number 2 object that we put in there, or whatever value, it's gonna add some code to identify it as number 1, which was in this case for a number 1, 2. So it's just gonna use it as that, and it's gonna immediately drop 2. It's dropping 2 to BB1. What's this BB1? So BB1 is something that we return. Actually, I have no clue how to read this part, but it does look like um, Rust has its ownership model somehow involved in here. And I'm not sure what drop does for Rust. Maybe it frees allocated memory of some sort. So this is almost like reference counting, maybe, inside there, but do you feel it? Do you feel it? Do you feel like you want to learn more? I feel it. I am very, very feel, as one boxer said, Ukrainian boxer. Let's actually remove that. No, let's use the other type we had in there. So this is now going to be str, and it's gonna be string from string from whatever I have here, and this is gonna be hello. Boom. Did I write it correctly? Did I mess up? No. So again, a number is associated to actual number 1. A string is associated with number 0. So whatever we have here, number 3 is a reference to AAA, which is this probably. And there we go, a string s from string with a constant hello. So this is a sort of a reference to number 2, an object for number 2, right? So B1 gets a number thing that we discussed before. Nice. So I guess this is further optimized later on in the compile time process, and we've got a nice program that cannot be broken. Cool. Well, now I really want to see how the hell the match works. Match B. So what was the syntax? AAA str s, then it's gonna print ln. So we're gonna output whatever we just received. So str and output s. We have it in scope, and we put this thing here, comma, and then we're gonna do the same with the number. Come on, NMR. This is gonna be n, and NMR. And this is gonna be n. And I guess we should be. Oh, we did cover every possible choice in the match. So did it work? It still worked. Nice. What was the execution? Okay, screw it. Let's analyze it first and then see. So maybe for match there's some extra functionality that's appeared in the MIR representation. A shit ton of things appeared. So we've got some functionality for NRM, for print line. So this is probably a function that is created for us to print out NRM for number. This is probably a function created to print out str when we get a string in the match. How is this promotion thing happening? So now, okay, so variable number 19 is probably creating a formatter. So is it for this? So it's getting a string, let 3, string, scope, whatever, debug, args, number 3. So this is getting a string, and this, oh boy, this is too much. And this, okay, so this is our checker for the match. Okay, we see a discriminant for 1, and then it's using promoted 1. Okay, so every time we call this print line, it's actually generated function with index 1 for printing out a number, printed promoted number 1. Promoted number 1 in main is something to print out number. See, holy shit, this is a lot, and it's freaking interesting. And but I don't really get how it's checking the determinant, discriminant, what? Description something. Okay, discriminant. I don't understand in this representation how it's working. Scope 1, debug, whatever, let something scope 2, blah 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 blah. Where is the freaking if? Where is if? So a bunch of pointers already using discriminant 1 and print bb3 and then whatever. So this looks like a main function actually. The actual main function, yeah. Scope 1. I like how it scopes stuff. Whenever it gets deeper and deeper and deeper, it just goes into scopes with every line. I guess every line in Rust somehow is another scope where it carefully checks for stuff that it can look at it. Cool. It's just cool. Well, I guess that's it. It's enough. Otherwise, the brain will hurt and we learn something. There's a lot of stuff happening. This is a layer that's obviously going to be optimized further in next representation of some sort, and it's going to generate more function calls to operating system and stuff like that, and it's going to generate more alloc, dealloc functionalities that we saw before, and then generates a binary of roughly 400 kilobytes, which is not that much. Okay, that's enough. Thank you guys. I hope you liked it.